to Cambridge Chemistry Channel with Sarwat Ahmed. This is question number 6 of 9701, May June 24, question paper 4-2. Let's start. Question number 6. Aqueous solution of methanoic acid and propanoic acid are mixed together and equilibrium is set up between two conjugate acid base pairs. Define conjugate acid base pair. Conjugate, we know that conjugate acid is proton donor and conjugate base is proton acceptor. So the conjugate acid base pair is the pair of species which differ by proton. Okay. The pKa of HCOOH is 3.75 and CH3CH2COOH is 4.87. Complete the equation for the Bronsted-Lowry equilibrium between the stronger of these two acids and water. So complete the equation. So this is the methanoic acid plus water to form methanoetine and hydronium. So this is acid, this is base, now this is conjugate base and this is conjugate acid. So this is why it is acid, because it is proton donor and it is proton acceptor. Water is proton acceptor, and this is conjugate base because it is proton acceptor now, and this is proton donor, so that's why it is conjugate acid. Write an expression for the acid dissociation constant K for the butanoic acid. So we know that butanoic acid, this is the butanoic acid, CH3 CH2 CH2 COOH, and to form CH3 CH2 CH2 CO negative plus H positive ion. So these are the NKA dissociation constant of acid is C product divided by reactant. So this is C2H5 3 and this is butanoate. This is butanate ion C3H7 butanoate ion and hydrogen ion, and divided by concentration of butanoic acid. The pKa of butanoic acid is 4.82. A solution of butanoic has a pH of 3.25. Calculate the concentration in mole per dm cube of butanoic acid in this solution. So dissociation constant is equal to Ka is equal to 10 raised to minus 4.82. So this is pKa. So how to calculate the concentration? The concentration of this acid is 1.51 into 10 raised to minus 3, and the concentration of hydrogen ion is of this solution is 3.25. so H positive ion is equal to 10 raised to minus 3.25, and the concentration of this solution is 5.25 into 10 raised to minus 4. So by rearranging this equation, because we want to calculate the concentration of butanoate ion in the solution, so concentration of butanoate is equal to concentration of butanoic acid of solution base 5.25 into 10 raised to minus 4 divided by 1, because this is the because butanoate ion is equal to the concentration of C3H7 COO negative is equal to H positive, so this is equal to H positive square. So the concentration of butanoic acid is divided by Ka. The Ka value is this, the Ka value is this, and hydrogen ion is this. So in this way we can calculate, by calculating this equation we get the concentration of butanoic acid. Define buffer solution: the solution which resists the change in pH with addition of small amount of acid and base. A buffer solution containing a mixture of CH3COOH and CH3CONA is prepared as follows. This is ethanoic acid and this is ethanoetine. This is weak acid and this is a salt of weak acid. So the combination of the mixture of weak acid and salt of weak acid is known as buffer solution. A solution of 600 centimeter cube of ethanoic acid is mixed with 400 centimeter cube of 0.125 mole per dm cube of sodium ethanoate. Now in this question, Ka is equal to salt and hydrogen ion over acid, and we know the concentration of hydrogen ion is calculated because pH of this solution is given. So pH is 5.7, so concentration of hydrogen ion is 10 raised to minus 5.70. The concentration is 2 into 10 raised to minus 6. Now number of moles of acid salt ion 0.400. This is the volume and this is concentration of sodium ethanoate. So the moles of sodium ethanoate is 5 into 10 raised to minus 2. So mole is equal to concentration because mole is in 1000 centimeter cube. So the concentration of ethanoate is equal to concentration of concentration of ethanoic acid is equal to concentration of salt, concentration of hydrogen ion divided by Ka. So we have the values of salt, concentration of salt and hydrogen ion. 5 into 10 raised to minus 2 into 2 into 10 raised to minus 6. So divided by Ka value, K is 1.78 into 10 raised to minus 5, it is given. So the concentration of this is equal to 5.60 into 10 raised to minus 3 mole. So we know that the concentration of acid is 600 centimeter cube. So the concentration of acid is calculated by using mole over volume into 1000. So this is the formula: mole over volume into 1000. Now we have volume is 600 centimeter cube, which is given in the question, into 1000. So the answer is 9.33 into 10 raised to minus 3. We know that the total volume of acid is equal to its solution is 600 plus 400 centimeter cube is equal to 1000. So concentration is equal to mole over volume, and we know that the HA, the concentration of HA is the mole is 0 divided by 1. So the answer is 9.33 into 10 raised to minus 3. So this is how to calculate the concentration. We know that the total volume is 1000, so that's why into the concentration of acid is initial concentration of acid is 9.33 into 10 raised to minus 3. A fuel cell is an electrochemical cell that can be used to generate electrical energy by using oxygen to oxidize a fuel. Methanoic acid is being investigated as a fuel in fuel cells. When cell operates, HCOH is oxidized to carbon dioxide. The half equation for the reaction at cathode is oxygen plus 4H positive plus 4 electron to form water. In this fuel cell, the overall cell reaction is the same as that for the complete combustion of HCOH. So HCOH is plus oxygen to form carbon dioxide and water, and we know that this is first equation and this is the second equation. So half oxygen is cancelled out. So by using these two equations, 2H positive plus 2 electron plus half O2, so this is cancelled. Half so you know that when if we divide whole equation with half, then by 2, then 2 to the 4, 2 to the 4, and 2 1 the 2. So water is also cancelled out. So these are the two equations. This is first equation, this is second equation. Two H positive plus 2 electron to form plus half O2. Half O2 is cancelled this equation, and water is also cancelled. So we have HCOH to form carbon dioxide plus 2H positive plus 2 electron. Electron is also cancelled. Plus 2 electron. So the half equation for the reaction is This is equation 1. We know this is equation 1 and this is equation 2. And we know HCOH, CO2, water is HCOO, H plus to form carbon dioxide CO2 plus 2 electron. Plus 2H positive. So calculate the volume in centimeter cube of oxygen used when a current of 3.75 ampere is delivered by the cell for 40 minutes. Assume the cell operates at room condition. This is time and this is current in ampere. So first calculate Q is equal to I into T. So I 3.75 into 40 minutes, 40 into 60, so this is 900 coulomb. And we know that in this reaction 4 electrons are used in oxygen. So 96,500 into 4 is equal to, this charge is equal to 1 mole for example, and 900,000 coulomb is equal to X. So calculating mole by dividing 9,000 divided by 96,500 into 4. So this is the equation. And we know that 1 mole molar gas volume is equal to 1 mole of all gases have volume 24 decimeter cube. So 1 mole of gas is equal to 24 dm cube. So the 9,000 into 24 divided by 96,500 into 4. So the answer is 0.5596 dm cube. So the it is in centimeter cube, so multiplied by 1000 to form 5559 in 0.6 centimeter cube volume of oxygen gas. Methyl red can be synthesized as shown in figure 7.1. So this is the conversion. Methyl red can be synthesized. This is the methyl red and it can be synthesized by using this. So step 1, this is nitro benzoic 2 nitrobenzoic acid and 2 nitrobenzoic acid. The reduction takes place to form this compound. In here reduction to form this compound, and then in step 2 NaNO2 plus HCl. So the temperature is below than 5 degrees centigrade, we get this compound, and then by reacting this, because this is the compound which is combined with this compound, so it is phenyl amine, and by condensing phenylamine and this salt, we get this compound. So give the systematic name of P. So this is 2 nitrobenzoic acid. and P can be synthesized as shown in figure. Suggest reagents and conditions for this reaction. CH3 is methyl, so potassium manganate, manganate ion, acidified potassium manganate, and condition is heat under reflux. A student attempts to synthesize P by an alternative route as shown in figure. Compound T is the major product in this reaction rather than P. Concentrated nitric acid, concentrated sulfuric acid. Explain why T is the major product in this reaction. T is major product because carboxylic acid is electron withdrawing group, so incoming substituent should be attached at 3 and 5 position. S react in a similar way to the phenol in step 3. Draw the structures of Q or S in the boxes in the figure. Already drawn the structure in the boxes R and S. Suggest the reagents and conditions for step 1 and step 2 in figure. Step 1, SN plus HCl concentrated. This is the reagent, and heat under reflux, and in this heat is and heated at below 5 degrees centigrade. So this is the condition for step 2, and this is condition for step 1. State the relative basicity of phenylamine, benzoylamine, and ammonia in aqueous solution. Explain your answer. Benzoylamine is most basic than ammonia, and ammonia is most basic than phenylamine. As benzoylamine is most basic, as the alkyl group is attached with this benzene ring, so alkyl group is electron donating and increase the availability of lone pair on nitrogen atom on nitrogen. So phenylamine is least basic, as the phenylamine is this structure. This is phenylamine, and lone pair is delocalized on the benzene in the benzene ring, so availability of lone pair on nitrogen atom is decreased, so that's why phenylamine is least basic. An excess of bromine is added to separate sample of phenylamine and benzene. Phenyl E part is phenylalanine, alanine C6H5. This is phenylalanine is an amino acid with an isoelectric point of 5.5. State what is meant by isoelectric point. Isoelectric point is the pH at which molecule exists as zwitterine, has no overall charge or neutral, or in other words you can say that the neutral point is the isoelectric point. So draw the structure of this compound at pH 10. So at pH 10 it is a basic so we can draw the structure like this: C6H5, CH2, CHNH, NH2, and COO negative. So this is the at pH, or in other words you can draw like this: CH2, C6H5, and this is H. can draw like this or like this. And alanine react to form a dipeptide containing both amino acids residue. So this is the structure of phenylalanine. This is the structure of phenylalanine, and this is structure of alanine. So you know that H from the alanine and OH from this side in the presence of concentrated sulfuric acid. So this is the dipeptide. This is the peptide bond. Question number 9. Explain why trichloroethanoic acid is more acidic than ethanoic acid. So chlorine is electron donating group which is attached with this acid, and due to electron withdrawing effect of chlorine, which able to weaken the OH bond in carboxyl, so it also able to stabilize the carboxylate ion. So chlorine is electron withdrawing group. Chlorine pull the electron on this side, which make OH bond weaker and easily break. So CH3, this is alkyl group, this is electron donating group, and positive effect of the carbon atom become minimized due to positive inductive effect, so which make OH bond stronger and difficult to ionize. So that's why it is more acidic and it is less acidic. Acyl chloride are formed by reacting carboxylic acid with thionyl chloride. Ethanediol chloride can be prepared by reacting ethanediolic acid with an excess of COCl2, SOCl2. Write an equation for this reaction. So this is the chemical equation for this reaction. COCl2 twice plus HCl plus sulfur dioxide. Sample of COCl2 are reacted separately with an excess of warm acidified potassium manganate with this compound, and with this the carbon containing product from the reaction with the diamine has the molecular formula C4H6N2O2. Complete the boxes in the figure 9.1 to suggest the structure of the carbon containing product in each reaction. CaCl2 are separately with acidified potassium manganate. So this is carbon dioxide is formed with this compound, and with this is when this compound react with to form, you know, that Cl and H. This is the byproduct, and this is the organic product. Left behind is the organic product. So this is formed like this. So potassium manganate when react with both species, with warm acidified and with this compound COCl2 with warm to form carbon dioxide, and when this compound react with this compound, this is COCl2 and this is diamine, 1,2-diamine, ethane diamine. So this is the organic product of reaction with 1,2-ethane diamine when react with acidified potassium manganate. And this is the reaction when dicarboxylic acid 1,2-dioic acid react with oxygen in the presence of potassium manganate. This is nascent oxygen to form, which is formed when acid is few drops of acid is added in potassium manganate. So this oxygen reacts with this compound to form carbon dioxide and water. A polyester can be synthesized from the reaction of COCl2 with ethane 1,2-diol. Draw two repeat units of this polymer formed. Any functional groups should be displayed. So this is 1,2-ethanediol, and this is COCl2, ethane 1,2-diol, and this is COCl2. This is the displayed structure of COCl2, and this is displayed structure of HOCH2, CH2OH. And now this is the repeat unit, and this is the ester linkage is formed when these compounds react, because this H and this Cl is eliminated, and this Cl and this H is also eliminated. So the rest of the compound is condensed to form this compound. So 2HCl plus 2HCl is formed, and the linkage is ester. So this is a two repeat unit, C double bond and CO, CH2, CH2, CO and CH2. Compound HC6H10O3 react with alkaline iodine to form yellow precipitate J, but does not react with Na2CO3. This is the compound C6H10O3, and proton HNMR spectrum of which in CDCl3. So CDCl3, this is H and this is H. This is the reference compound, and the peaks are at different points. You know that at 1.15 peak, 1.15 peak is of CH2. So this peak is this CH2 has two hydrogen, and triplet peak is like CH2O, CH3. So this CH2 is responsible for this peak because hydrogen atoms are 2, and n plus 1 rule, according to n plus 1 rule, is equal to hydrogen atom is 2 plus 1 is equal to 3. So it gives triplet peak, and this peak is responsible for electronegative atom, and this compound is like this is the compound CH2CO. CH2 C double bond O. This peak is singlet peak. C double oxygen electronegative elements give singlet peak, and this peak is responsible. So this is around about 3.5 or 6, 3.3 and 3.2. This is 3.5 and this is 3.6. 3 to 6. And this is round about 3.2 to 4, and this peak is CH3 CHO. This is CH2O peak. This peak is CH2O peak, and this O is oxygen gives singlet peak CH2O. Next to electronegative element, alkyl next to electronegative atom, and this is a triplet peak, and this is like CH3. Responsible is 3ACH3 because this is quartet peak, and the neighboring atom is CH2O. This is the neighboring atom. So this gives quartet peak. This CH3 gives quartet peak, CH2O, and this is about 3.924. This is 4. CH3O, CH2O, CH3O, alkyl next to electronegative atom. 4.5 till 4, 3, 3.94 CH2, and neighboring is CH3, and CH3 is hydrogen atom 3, so N plus 1, 3 plus 1 is equal to 4 quartet peak. Identify yellow precipitate. Yellow precipitate is CHI3 triiodomethane. Complete table 9.2 for the proton HNMR spectrum of HC6H10O3. So 1.15 is the triplet peak, 2.25 is the singlet, and 3.60. This is 3.60. This is 3.60 is the singlet, and 3.95 is the quartet peak. And the number of hydrogen responsible for this peak 3 hydrogen atom, singlet 3, and singlet 2 hydrogen atom responsible for singlet peak, and 2 hydrogen atom responsible for singlet peak. And singlet peak hydrogen adjacent carbon at number of protons, some non-adjacent carbon atom is 0. It is 0. So quartet, you know that this is the responsible CH2 is responsible for quartet, and this carbon which has no hydrogen atom responsible for singlet peak, and this is oxygen atom responsible for this hydrogen is singlet peak 3.60. So carbon has CHO, this carbon atom has no hydrogen atom. Suggest the structure of for C6H10O. This carbon 1, 2, 3, 4, 5, 6. 1. This is 1 carbon, 2, 3, 4, 5, and 6. And C6H10O3. So this is all about of this paper. Hope you will understand, and if you like this, please share and subscribe my channel and like this video.